If I actually might have all the slides.
You have S and I. What about Russ's?
Yeah, I got this up too.
Oh,
2, 4.
well, TLS and DTLS and connection ID are all on the same one.
1, 2.
So we're gonna. Which order is it in?
So it's going to be this. And then you connection ID. It's ordered up in the headers. Back compression. Semi-static.
Semi-static's up there. What's the order again? I'm reordering them. DTLS. S&I encryption. Yeah, that's good. Is that uploaded?
No, I'm not going to upload it.
So connection ID, DNS section.
I think we're good.
Recorded or authenticated. Are these in the right order now? We should get started.
Yeah. Semi-static. Yeah, that's right.
All right. Okay, folks, this is the TLS meeting. We're going to get started in about a minute. What's the matter? What do you need?
This is one of those load everything, turn it all off.
Okay, welcome to the second session of TLS this week. Once again, you should be familiar with the note well. The blue sheets are going around the room, so please sign them. And as always, when you come up to the mic, please state your name and keep it professional. So we have a pretty full agenda today, but it should be stuff we can all get through. A little less controversial than yesterday or Monday. Yeah. So, okay. Yep.
So, excuse me, one of the things that we do typically at an IETF when we have a change of leadership, which will happen later tonight, is we present a gift to our outgoing area director. We have such a thing. So Kathleen, please come to the front. We're going to provide you some wine to drink after Monday. There you go. Thanks a lot.
And thank you all for the work that you do. So,
All right. We're not going to do the document status because nothing has really changed other than a new version of TLS 1.3 popped out and it's been pressed for approved. So it's going the RC editor's queue. We're very happy about that. But if we find anything, we're pulling it back. That's been the deal all along. So everyone should remember that. However, to commemorate that, we did make some stickers. So we're going to give out some stickers and you can, take some and pass them around. Had some other things planned, but it's stuck in customs, so that's life. All right. Do you want to go ahead and kind of hand these out there? Go from there. Don't take them all. We got a lot, but just in case. And so that's about it for TLS 1.3, quick minute and a half. So now we're going to move on to DTLS and connection ID. Yeah, we should be done. All righty. Ecker, you're up.
So it turned out that like the only thing I wanted to talk about with DTLS 1.3 was the same thing I wanted to talk about with connection ID. So we're just gonna glue those together. So I'll let you figure out which part of the talk each part is. Next slide, please. So when we started, so when we first did like DTLS 1.3, we thought about putting a connection ID in, and then like people were sad about that. So we took the connection ID draft out, and then people were like, why don't we do a connection ID draft that does DTLS 1.2 and DTLS 1.3? And I was like, sure. Not that I really cared, but sure. And but it turns out that actually a lot of demand for DTLS 1.2 connection ID today, because a lot of people have DTLS 1.2 now, and they're gonna have DTLS 1.3 later, but they can wait a little longer for that, but it's annoying them now that it kind of sucks with 1.2. But on the other hand, we got a little stuck on exactly the right way to encode the connection ID headers. And so I had this idea yesterday, which was basically, there's a little bit of a question about whether or not the DTLS 1.3 headers that we're proposing are exactly what we want. And also there's a bunch of conversations quick about maybe we should steal some of their stuff or maybe, whether they should be the same or whatever. And so maybe we're gonna want to screw around with that a little bit. So keeping the door open for that is good. But on the other hand, dragging down DTLS 1.2 connection ID while we think about DTLS 1.3 connection ID, not great. Next slide. That said, there is a sort of technical issue in principle we need to resolve that we need to do if we're going to do this. If you're going to have in Quick, there's always a connection ID, but we have a big installed base of DTLS 1.2, and that does not have a connection ID. And so a server, a client or a server, most likely a server, may find itself in the position where it has clients both support and do not support the connection ID, extension. And so now they get packets and they have to determine whether they have a connection ID in them in order to route them down the right pipe. That is to do whether to do 4-tuple routing or to do CID-based routing. So it was suggested that one way to do this, the obvious way to do this, is to have an indicator bit in the header that says connection ID present or connection ID absent. As I'll be explaining in a minute, this isn't like necessary. You can make it work without this, but it like is convenient for various kinds of like packet parsing. It's particularly convenient if you're like something passive and special like Wireshark, where you don't know exactly what the server's behavior is. This might be a little less necessary in 1.3 than 1.2, because in principle you could have like a 1.3, 1.2 CID, no CID server, and like refuse to negotiate 1.3 if like they didn't do connection ID. So that might help a little bit, but regardless, it's a real problem for 1.2. So in 1.2 and 1.3, the 1.2 and the 1.3 long header, there's like a lot of wasted space. So you're allowed to have a length of up to 64 kilobits. In principle, like there's not bits for it, but you can only have, but like 2 of those bits have to be 0. And there's like a full byte for content type, but like we have like 20 content types. So there's like a lot of space there. But when we did the DTLS 1.3 short header, we like packed everything really hard down, and so there's actually no extra space at all. And in fact, as I'm about to say in a minute, there may actually be a little less space than you'd like to have. So we didn't know what we're going to do, like, enough with 1.3 with 1.3 to make sure that we're not like taking a path in 1.2 that screws everything up for 1.3. Next slide. So there are basically two technical options here, which I've been calling implicit and explicit connection IDs. Worth noting, Quick has decided to do both. In the Quick long header, it'll be explicit connection IDs. In the Quick short header, it'll be implicit connection IDs. So Merry Christmas. So if you want to do implicit, but as I say, in Quick, that's easy because in Quick, you know whether the thing is present or not. So, it's easier. Important to remember that in DTLS 1.3 and now in Quick, the receiver controls the connection ID. So, you have an opportunity to construct the connection ID in a way that's easy to demux. Everything here should say DTLS instead of TLS. I've written TLS so many times, I have trouble writing DTLS, but it actually, true story. Like I type TCP as TLS lots of times. Anyway, regardless, in the current headers, the connection ID goes right in the long header in DTLS 1.3 and in the TLS 1.2 header, the CID goes right before the length. And so all you need to do is determine where the next byte is length or CID. So because lengths greater than the 14 are forbidden, if you just set the high bit in the CID, then you can like look at that and you know it's the length or a CID. Now maybe you have middle box problems, maybe you don't. That's your fault. That's your problem. But like regardless, you'll be able to demux. So that's unambiguous and very straightforward. The short header is harder because there's no length field to demux, and so the thing you're demuxing against is like just random trash. But that gives you an opportunity too, which is basically you fix the first n bits of the connection ID to something, and the server knows what that something is. And this is the first n bits of the ciphertext are random. Then if you do the chance of collision is 2 to the minus n, right? And so you can pick any error rate you please by like the cost at n bits. And then if there's some the 2 to the minus n rate of false positives, and if you get a false positive, you try to decrypt, and if it fails, you can either discard the packet or you can be like, oh, now I'm going to fall back to n-tuple routing. So this is my argument that it's not in fact necessary to have any extra indicator bit in the protocol proper. That said, one might think this was nasty, and particularly for like Wireshark guy, you might think this is like really nasty because you don't know, because server A chooses the magic string FF and server B chooses the magic string like dead beef, and like, you don't know how to parse it. So you might think that you want like a bit. Next slide. Again, the thing we got stuck on is like the bit, like for the 1, 2 in the long header, this like seems like an aesthetic choice. Namely, it's like, there's a bit, we got lots of room, so like really like just aesthetic, right? But the short header, because I have no room, it's actually like we have to pay for that somehow. And the crappy part is like we pay an entire byte for it because we have no room. And we're not gonna we're not gonna have the like ciphertext not be byte aligned because that would be crazy. So we need to redesign. On email, Thomas suggested expanding by 1 byte and using some of the bits for flags. Now, separately, it's occurred to me that we may have crammed the header down a little too hard, and the DTLS 1.2 sequence number in the short header is like 12 bits. And it's actually quite possible to have a situation where like you're overflowing that 12 bits and you're forcing the long header just because you don't want to have the ambiguity about the sequence number. I was sort of against this, and then I started thinking of the sequence number being too short, and I started getting more for it. So what I'm about to show you is like one of a number of options for basically trying to like make lemonade out of this lemon that arguably like makes the world better and solves several problems, and also gives some space for the CID bit. It's important to note this is not the only way to do this. There's a number of options. What I'm hoping to get consensus on today is like that we think this is like worth doing in principle, and then we can discuss how to pack the bits later. Next slide. So here's like one design. We rob the first byte we take the first byte, and remember it has to start in 001 for deconfliction reasons. And then we assign 2 new bits, C, which means the connection is present, L, which means the length is present, and then the next 3 bits are just XXX. They're just reserved. We probably have to grease them, but that's easy enough to do. And then the epoch and the sequence are packed together in the remaining 2 bytes. So we have 3 byte headers, that is 2. So this gives you a 2-bit expansion of the sequence number, which gives you quite a bit more room, and probably is enough room for anybody, because it's pretty hard to get that far out ahead of it. This is not the most optimal packing. This is the packing that gives you the most flexibility. There's another alternate packing, next slide, which I'm not going to actually show. But I guess, like to point out, this gives us one header format, not two, because you don't need to have the detail ciphertext and the detail short ciphertext. This can carry both, because basically you have enough room, and you have enough room for the 2 epoch bits, which is why you needed the long version, and you have enough room for the length, and you can have the length be optional, so you can do piggybacking or not piggybacking at your discretion. It gives us 2 more bits of seq number, and as you see, we have at least three more flag bits if we want them. Another possibility, if we decided we wanted a longer sequence number, is to shove the 2 epoch bits into go back for a second, into those 2 XXs, and then we have one more flag bit remaining if we wanted it, and then we have a 16-bit sequence number. There's a variety of other things you could do too. You could you could also have one of those bits be like how long the sequence number is. So you can have allow an 8 and a 16 or an 8 and a 24. So like a lot of stuff you could do here, right? Depending on exactly how much flexibility, the flexibility versus like compactness trade-off at this stage of the game. So next slide, please. So I sort of like, and again, we don't need to do exactly this. We might at the end of the day decide to rip off the quick headers, which have other merits or demerits. So I think the question I want to ask is like, if people is this sufficiently persuasive to people that this makes them comfortable with having a CID indicator bit? In which case we can have a CID indicator bit, we can close the TLS 1.2 issue and spend a little time bike shedding about the structure. Next slide. Which I think this thing I just said. Right. So I mean, I guess that's the question I think we should focus on is, do we want this bit at all? If we do want a bit, if we don't want a bit, then we can just publish the CID draft and be finished. If we do want a bit, then we can just basically define this piece of details 1.2 right away, and then there's some question about whether or not it's best to use the content type or the length. Martin argues that it's best to use the content type, which I think he's probably right about. But one might think about the length where there's bits in either place. And then we can spend a little time tuning the details 1.3 format because there's no actual there's less urgency for dealing with that. So I guess I was eventually persuaded this was the right answer was to have the bit and to go that way. But I'd like to hear other people think.
Hi, this is Hannes. So I was previously more in favor of the implicit approach, but now I'm leaning to the explicit one that you proposed. I think it's just cleaner. I also like this new header design. I don't care much on whether we encode the information in the content type or in the length field. I don't have an opinion about that. Also, the sort of split or having a 2-stage approach, first trying to do something for 1.2 appears to be better because that's where what people are currently deploying and using. And if we could get them to support this functionality as quickly as possible, that would be very useful. And for DTLS 1.3, we have a few months, additional months time to do that. So I think it's a great idea.
Ben Kadak, are there any privacy implications you want to talk about having the CID bit versus not?
We probably should mention something about that. I think generally my sense is that it's pretty obvious when the attacker can generally tell when the CID is present because CID is constant. So I don't think it's I think it's like one of these things that is extremely annoying to parse, but actually doesn't have any privacy impact. I mean, the CID existing is a privacy impact, but I don't think it's doesn't tell you much of a secret that it's there.
Thomas, I'm in favor of explicit, as you know already, for all the reasons I've already stated on the mailing list and offline. I think this design is fantastic. It's very, very good. It destroys the false dichotomy between short and long. It's just fantastic. So you unfold the header, you fold it on opportunistically. So thumbs up for this.
Tobias Gonner, Huawei. I'm in favor of the explicit version, mostly for the same reason as Hannes mentioned, because it's cleaner. And I'm really scared of things like magic number type of approaches. And the first one has that kind of feel and this potential volatility about unpredictable behavior. So I think that's better. The second comment I would make is if we can see that we can do this relatively soonish, that would be very good because there is a lot of need out there that's really waiting for this to be finalized. Thank you.
So what I'm proposing to do is I'll split the draft into two pieces, one for 1.2 and one for 1.3. And we can publish the 1.2 one as soon as every issue is resolved. And the 1.3 one, maybe we can publish it immediately too, but like that would, then we won't have to, then we can spend more time thinking about that in a little bit of leisure.
So Martin Thompson, I've previously been pretty strong advocate for the implicit one. I just like to make it clear that what we gain in this case really largely accrues to middle boxes, routers, load balancers, tools and whatnot. And that's not a bad thing. I think based on the discussion here and talking with people, I think that this is probably the right design. I have plenty of paint if we want to talk about
Yeah,
it.
well, we're painting it later.
We can certainly paint that later on. There are only so many options that preserve a reasonable balance between size and you got to balance the size of the sequence number against the size of the header. But that's something we can do.
Right.
I don't think we can steal Quick's design simply because of this
The
001
demux, yeah.
demux
Yeah.
concern that we have.
Yeah.
But I'm not cut up about that.
Right. I do think there is a piece of Quick design we're going to try to want to steal, which is encrypted sequence numbers.
Yes, that will be an interesting discussion based on the private discussions I've had about encrypted sequence numbers.
In Quick, right?
Yeah.
Well,
Yeah.
I guess what I would say is I think the DTLS and Quick should agree about the encrypted sequence numbers because they're almost exactly the same setting. And
Yeah, that's going to be fun.
I agree.
Thomas, there's also the point about feature parity between 1.2 and 1.3 in terms of seed update. I think we should also
slides are coming.
discuss this. Okay.
Next slide. So I think sounds like people are okay with this way forward.
Yeah, does anybody oppose to explicit? All right, I think that's the way forward.
Okay. Right. So second issue is if you have multiple CIDs and you do a path change, and the sequence number is just like a linear, then like you instantly there's no point in multiple CIDs because it's like this is like FF01 and this one's FF02 and like the CID is random, but it doesn't matter because what came next, right? So we need to do something. And in 1.2 so I mean, like in Quick, currently Quick has this thing, which I think I invented, which is like random skipping based on like a digest of the current traffic secret. And so the idea is that like basically when you move to the next CID, there's basically you compute a KDF and that tells you how much to increment the sequence number. So for 1.2, like let's not get clever. We can just use exactly the same trick. Now, you don't like it, Martin?
Yeah. So Martin Thompson, I think the skipping trick from Quick is kind of annoying.
I agree.
And we can come up with I think rather than use the skipping trick where you effectively skip sequence numbers, I think we should probably move to what is effectively ROT13, and so that every connection ID has an additive factor that you add to the sequence number, and you just remove that addition when you decode.
So certainly I could imagine doing that. I guess I'm trying to go for the minimal change in 1.2.
I think that's less of a burden for implementations.
Okay.
So,
Why like to hear other people's opinions about that? Do people have it? So I guess what Martin's suggesting is essentially you do you can compute it the same way. You compute it you compute instead of computing a skip, you compute a random add, and then you add it modulo to the 48 in this case. So like there are two approaches. I think I'm not sure that.
So the advantage of doing that is that you don't have to worry about the strict sequence of connection IDs as they come out.
I see.
And that's the primary advantage. So the current Quick design requires that you apply all the connection IDs in strict sequence because the skips are cumulative.
Yes.
And in this case, you would simply just say that every connection ID has a corresponding add, and then you just carry on.
Sure.
I
think that's fine.
Christian Wittemer. I just wanted to remind Martin and you about why we don't like is CID-based skipping in Quick. Is that if you have any kind of overlap between using the old CID and the new CID, then you can very easily deduce what the skip was, and you have no privacy.
I agree. So I think this is like far from ideal, which is why this is far from ideal, which is why I'm proposing in details 1.3 we go much further. So I think Martin persuaded me. So I think from the amendment, I suggest we'll write up the addition trick instead of the skipping trick. They're actually quite similar mathematically. For 1.3, however, I think we should encrypt the sequence numbers. And this is going to take a little time to work out. I think we need to figure. We should use the same. Like again, Quick and DTL should harmonize on how to encrypt the sequence numbers. Either they should do it or not do it, and they should do it in approximately the same way. So that we're still screwing around with that in Quick. So I think like I suggest we just like this. It's like all the same people. like it's me and Martin and Sabode and Praveen. So I think like we get like in sweat. So I think like we can just like figure it out and like then come to both places with the same answer.
Yeah, Sabote's going to tell you that this is a bad idea because he's going to change everything in Quick.
Oh, is there a different plan, Sabode? Not have sequence numbers?
No, Subodh Iyengar. I had a slightly orthogonal/related point to this. I just reread the draft of the connection ID, and I didn't notice this before, but it seems like the DTL's connection ID is not in the authenticated part of the header.
Oh no, it will be. It will be in 1.3. Well, so in 1.2 we can do anything we want, and in 1.3 it'll be part of the header because all the higher headers are authenticated.
Okay, thanks.
I mean, 1.2 we'll have to write that down, but thanks for reminding me.
Tobias Gondrom, Huawei, and I think I'm going to say something stupid now. From a minimalistic approach, the most simple thing that we would need is just a mechanism to update the CID. Doesn't have to be continuously updating whatever. It's like imagine the device calls only once per day.
I have a slide on that. I have another slide on updating, by the way.
I'm sorry?
I have another slide on updating. That's my next slide.
Okay, because if you are able to update, that fulfills the privacy requirement, in my opinion.
No, unfortunately it doesn't because the sequence numbers are high entropy values. And so they're not necessarily high entropy values, but say you have trivially, say you have two devices, right? One of which has sent 1,000 packets and one of which has sent 5,000 packets. If you then randomize the CIDs and look at the sequence numbers, or just erase the CIDs, then you can tell which one's which by looking at which one goes to 1,001, which goes to 5,001.
Okay, so if you have later mechanism to
I do, it's the next slide.
then I'm happy either way.
Yeah, that's my next slide.
Yeah, so Martin Thompson, that what I was hoping Sabode would tell you is we're looking at having different sequence number spaces in Quick, or at least some people are anyway, which would remove some of the problems.
You mean for each CID?
For every connection ID would have its own sequence number space. And so the additive trick would work again there because you wouldn't, as you switch between the two of them, you would pick numbers from those spaces. And so that's an ongoing discussion.
So I mean, the additive trick works in either case.
It doesn't work with the alternating case. If you alternate between two of them, you can correlate the gaps.
Yeah, I agree. So I guess like we can talk about this later, but like I strongly prefer encrypted sequence numbers. It conceals more information.
Yes.
Because the additive one still shows the linear sequence for like any given flow, right?
That is my preference too.
So again, like I think like this seems like something the IETF ought to be able to agree about as a general policy matter, and then implement. I mean, with two protocols like extremely similar like conceptual wire images, we really ought to be able to agree on what those two protocols do for like the same data values. Given that like I'm pretty sure the people who care are like exactly the same people. Okay, so to recap, what I propose to do is do what I said here, except cross out skipping trick and write adding trick, and I'll write that up. Okay. Next slide. Okay. So last point, and I guess I should have in the opposite order, is CID update. Currently, the draft has a DTLS 1.3 post-handshake message for CID update, which, like as far as we can tell, works fine. It doesn't do anything for TLS 1.2. There are three options for 1.2, as far as I can tell. One, continue to do nothing. I think we've heard that people don't think that's a great idea. Though, by the way, if it was a good idea, then like we could not have to worry about the additive trick. The second is do it in a re-handshake, which ordinarily like we hate re-handshake. And I still continue to hate re-handshake, but on the other hand, like defining the mechanism also I hate. And the third is to port the post-handshake messages into DTLS 1.2. I'm not like super enthusiastic. I'm kind of frankly leaning towards re-handshake, even though I ordinarily despise it.
So previously, when we've had people try to request backporting all of the issues into previous versions of the protocol, we've shot them down pretty strongly. So I think maybe we have to maybe eat our own dog food here.
I think you have to require EMS to make this acceptable.
So Martin Thompson, yeah, I'm leaning towards re-handshake too for the same sort of reasons. There is no way I want to implement all of the acknowledgement mechanisms necessary to get this to work in DTLS.
Oh, that's a really good point.
It's awful. It's like a huge lift.
That's a good point.
And none of the machinery exists.
It's true you need the act. Yeah, good point.
So I'm either do nothing because, well, renegotiation sucks, or requiring.
Well, these are actually the same thing, it turns out, right?
Well, yeah.
I mean, do nothing and require handshake are the same thing, right?
Yeah.
Is basically, all we do is you write the extension and say the extension applies immediately, and then we're done.
Success. Yeah. Don't say anything. I think you probably have to say what it does in the case of negotiation,
right.
Frankly, but that'd be fine. I can live with that.
Right. And one thing that's worth noting is that is going to have a somewhat negative impact on privacy because you're not going to be able to, I mean, it won't be hard to conceal. I mean, so if you re-handshake and then you start using the new connection ID right away, basically that doesn't do anything. So I hadn't thought that through until just now.
So I guess the point here is that the reason you do the connection ID update is primarily to break linkability. And if you have to do an entire handshake at the point that you need to break linkability, you're kind of boned. So I think we can say that you can change the connection ID using this technique because we're not going to stop someone from renegotiating, but you should also point out that it's really not going to help them in the case that they want to break linkability.
So, okay, that comment, okay, Tobias gone on my way. That comment just, I need to get my head around this. So do nothing, I think, is not acceptable. Like if we can't update the CID that
So why do you want to update the CID? Let me ask that.
Privacy concerns. So is this a strong constraint? Hard to tell. But the ability to preserve privacy, that is probably a strong requirement for some people. Whether it's actually happening is a different question. And that the cost is maybe would be a re-handshake, that would be acceptable. What I just heard is that actually that will not protect you in linkability.
I mean, so the problem is you need to supply a new key ID on connection A, on path A for later use on path B, right? If you don't change the paths, that's worth anything, right? So in Quick and in the 1.3 mechanism, what happens is you can supply a pile of ones, and then the idea is that you use it the next time, right? But those are supplied under encryption, otherwise it's useless, right? And so,
Unless we're going to change the handshake completely.
what, allow multiples in the handshake?
Yeah. So the idea it's a terrible one. You find a new extension that says spare connection IDs.
Yeah.
And you pop that in encrypted. Well, you can't do that in detail.
No. I think what you do in I think you're like I get on the track. I think what you do. I think there's a simpler way to do this, which is like even cruddier. But like we'll call it spare. Would be great. We call it. Or we can call it many. But the bottom line is we just make the cardinality of the connection IDs more than one, and it's and then you offer it in the extension and
Encrypted.
No, I understand. But then in the re-handshake, it is encrypted, and then you can offer as many as you want, and then you're good to go.
Okay. Right. Gotcha.
So I think that's like repulsive.
It's repulsive.
And we just say you can't do that on 1.3. You say you have to offer 1 on 1.3 or something.
Yeah,
Right.
sounds good.
So I think we have an answer. To recap the proposal, Martin and my grotesque proposal is the following, which is we change the minimal extension that does the offer answer to allow more than one connection ID, and then with the semantics that they're all co-equal, basically, right? And then in the initial handshake, there's no reason to offer more than one, and we can even prohibit it. But in the re-handshake, You can offer a shit ton of them, and then you can, and then you now have enough that you can change when you go multipath.
Yeah, so that was basically my point. Like in Quick, we're trying to support a mode where Quick client can kind of prime a new path before it uses it, and so it can, and the new path when it does a path challenge request, it would potentially get a new connection ID, but it won't use it immediately. So should we put like a concept in here for, I don't know, maybe it's useful for DTLS as well, that is priming a new path.
Yeah.
If you want to do so, then you can store a path, connection ID for a path.
I think we can make that work. I can write that up.
Okay.
This will give you what you want.
So Tobias from Huawei again. So I think that should work. The embarrassing part is I don't actually even know how many end users will really demand this, but I'm facing with the demand that, oh, if you're not able to preserve privacy, then you're kind of.
I mean, other thing,
I
yeah.
think if it's a little bit costly, it's okay, as long as we can get something that can at least fulfill the basic requirement of privacy in 1.2, then that should do the trick.
Yeah, I mean, it's easy enough. It's easy enough to implement in a cheesy way by just like only sending one and ignoring anything but the first one. So I mean, like, it's not actually real implementation cost unless you want this.
So relaying for Victor, I am confused about privacy concerns. I thought the main reason for backporting CID to DTLS 1.2 was NAT rebinding from IoT devices and such. Those implicit migration scenarios keep CIDs the same. Victor Vasilyev.
It's Google creating.
Okay, Xin from Huawei. And the first thing I think we need to support it, and for the
Can you watch the microphone?
support updating. Okay, sorry. We need to support the updating the.
No, you're like this.
You gotta eat it.
Okay, sorry.
There we go, yeah.
Well, the first one, I think that we need to support updating CID in the 1.2, and the second, I think require re-handshake is not a good point, since you said in the LT scenario, such as the water matter, it will send only one message one day and then it will go to sleep. So re-handshake really costs the energy very much. So I think this is maybe not a very good way.
I hear you. I mean, I guess like the point Sean made, but I'll perhaps make more sharply is we're not really working on details 1.2 at all. And like even doing this much to like make the details 1.2 case work is like a big lift for working groups that's trying to move on to details 1.3. And so like, given that we don't know how to do this in a like efficient way in 1.2, I mean, if people are like, well, the re-handshake is useless, then we won't do it. But if they're like, that's fine. But if like people are like, the re-handshake is annoying, well, like that can just do something 1.3.
This is honest. I agree with Victor, who mentioned that the main use case was the NAT rebinding, and there the private concerns are different than the ones discussed in Quick, where you have things moving around. I think we should aim for something that gets done fairly quickly. Re-handshakes are not really that common in the IoT case to begin with. So if we have something, even not doing anything for 1.2 and just have the basic functionality in there, I think for me would be enough, and then move on to 1.3 to actually provide the full functionality there, because there we also have additional privacy mechanisms for the initial handshake, because for example, with the client authentication in 1.2, you're actually exposing that the client, for example, the client certificate as well, which also is a privacy risk on its own. So I think the plan should be moved to 1.3 as soon as possible.
Yeah. So another IoT voice here. So as Hannes says, we're seeing basically every time the node goes upstream to the mothership, the path changes because the NAT box loses the binding. So yeah, ideally, we should have a different seed for every. So yeah, probably the.
Yeah, I don't think. None of these mechanisms are designed to support that, right? I mean, you could sort of bang that into the 1.3 mechanism, I suppose, but none of these mechanisms are designed to support that. I think like I spent I spent hours and hours of my life trying to figure out how to build an efficient rotating CID mechanism and just gave up. So, and look, I mean, like,
I was hoping to use it in 1.2, but.
yeah, like I said, I'm going to ask the chair how to manage this because like I would do nothing.
I mean, so at the end of the day, right, if we end up trying to like get all these great features, we're redesigning 1.2 to look a whole lot like 1.3. So I think what we're looking for is a sweet, quick win, and then we move on and actually like try to do 1.3 the right way.
Okay.
And then we just kind of have to like literally let the implementers decide, right?
On a side, so I looked at the post handshake message and specifically some of that features in 1.3. And if you backport that into 1.2, there's not a small change to the TLS stack.
Yeah, I don't think that's viable.
That's really painful. So that feels a little bit over the edge to me.
Yes.
Tobias Gordon, Huawei. So do nothing, I think that would not be okay. As I said, we actually, even just from IETF perspective, we need to address the privacy considerations for that.
So for 1.2, I don't actually think that's true. We're kind of dancing on a line here, right? We're charted to do 1.3. We kind of are doing this kind of like as like a strong favor.
Okay, then I think if you go with the require rehandshake, that should be minimum change, because basically you're doing nothing. You just say you do a new handshake. That would be hurtful for IoT devices, but if you want a privacy, okay, you have to pay a price. I like the idea that you mentioned before with the set of IDs. If that's too much, okay, I think, yeah.
So Martin Thompson, I think we've kind of hit the sweet spot here. Tobias's objections notwithstanding, I think that, yeah, we're doing this because, yeah, it's going to take a little while for TLS 1.3 to deploy, and people are kind of out there hanging for this anyway. So it fixes the NAT rebinding case rather well, I think.
Which was originally the driving force
just
for
having
getting this.
connection IDs at all fixes the primary driver, and we provide more incentive to go to DCLS 1.3 if we do nothing like that.
I think that's where I am too now.
I think Martin's assessment is fair.
You're the chairs. I just stand here.
May I just raise one more question? Because maybe I'm not getting it. So the re-handshake, would that be a major change if we say you have to do a re-handshake?
No, I mean, so it's easier for us to say you have to do a re-handshake. What's a non-trivial change is to supply multiple connection IDs in
Okay, but then I think.
I mean, we don't think re-handshake does anything. That's not what we're saying.
Yeah, it doesn't really help.
But I mean, we're happy to, leaving it in is fine. Like, we're not taking it out.
Considering that the consensus around me is against doing anything, so then a re-handshake would still be better than nothing.
I will make clear that you could re-handshake to change your CID. That's a normative change, just text. Okay?
I mean, knowing that this is like not the greatest thing, but we are working on 1.3, does this sound like a way forward that we can kind of like live with 1.2? If you're in violent objection, please get on the 1.3 design train.
Okay, I will revise this draft by making, do I need chair approval to make a second draft?
No.
Okay, I'll make a second draft, like split them up and do the thing.
I mean, we'll have to approve it, but.
Yeah, sounds good. That's all I have.
All right, we're shockingly ahead of time. What are we doing next?
DNS.
Good, we're gonna need it for this one. All right, Shuman.
So Sean, thought occurred that we might actually have enough reason, particularly with the intrusive changes to the short header here, to actually just move the connection ID to the DTLS 1.3 spec. So it might be worth considering that as an option as well.
Okay. All right, folks, so this is a draft that's been lingering in the working group for a while, got all the way to the ISG, and then we had some discussion. So we're basically bouncing it back to the working group to try to deal with the questions and the open issues. And I know that Victor is probably remote, so when little Pac-Man comes up, please let us know because I can't see the thing, and then we'll whack him in the button. Oh, there it is. All right. So thanks.
Thanks. Can you hear me, folks? So we're going to talk about the remaining issues with the DNSSEC authentication chain extension. So this has been through IESG evaluation. There were a number of comments and discuss issues raised. We believe we've resolved most of those on list with the exception of one of them. So we're almost ready to push out a draft 07. Next slide, please. So this is the remaining issue. There was an inadvertent keyword discrepancy in our description of the mechanism for TLS 1.2 versus 1.3. So it says, servers receiving a DNSSEC chain extension in the client hello and which are capable of being authenticated by Dane may return an authentication chain. That's what the original wording said for TLS 1.2. At some point, we did version-specific descriptions of the mechanism. And for the 1.3 description, I think just accidentally it said should, right? So the question is, I had suggested on a list that maybe it should be should in both places. And I think Eric pushed back and saying we need to figure out what the working group consensus is. So that's why we're here. I think we were waiting for some feedback from the working group chairs and AD about this specific issue.
Yeah, so the reason why this came back is obviously because we're changing the 2119 language. So we can't just willy-nilly do that from under you guys. So discuss.
Well, I just speaking as AD, I don't care which one of these it says. I just think my position is the working group has to decide. So that's like
Yes, that was clear. Thanks.
Okay,
At least for me.
Yeah.
thanks.
Not in Thompson. This is not an interoperability requirement. You can say can, and everything works. So the fact that the extension exists makes it permissible, but this is not a choice that you make on interoperability grounds. It's simply a choice that you make as an implementation choice, basically. Do I choose to paint it red, or do I choose to paint it red? So I think we just say can.
Okay, yeah, we can do that, but so I want to come back to this issue later because of the point that Victor raised, which may actually have an impact on the wording that needs to go in here.
Richard, there's no special wording here. Like, if you want to use the feature, use the feature. If you don't want to use the feature, don't use the feature.
Okay.
This is like, do it if you want, don't if you don't.
Daniel Kahn-Gilmore. It strikes me that if you're writing a TLS stack that complies with the RFC that this will produce, then you should return it. If you're not writing something that complies with this RFC, then this RFC doesn't apply. So just use should in both places because you're describing what someone should do if they're implementing the feature in an interoperable way.
Okay.
Valvaris, I think maybe you're talking about whether or not you can stop using this extension at any point in time, which is unrelated to this slide, or?
So that's coming up later. I think that's part of Victor's discussion, so let's hold it until then.
Speaking of individual, I mean, again, I just don't care what this language says, but like the attempt in the standard to like exhort people to do things that like either they do or they don't want to do, I just like seems like it's even silly.
So, I mean, literally you could drop the word and say via Dane returns a serialized authentication chain because it is what it does, right?
Wish to be authenticated via Dane.
Yeah, I mean.
Like, if you want to do it or you don't. If you do, you're gonna have to go do it.
Okay, so I guess that's one possibility. We can reword this to remove these 2119 keywords.
Yeah, let's.
Okay.
All right.
Did you have another question? All right.
Wait for the next one. He's like shark in the water.
Next slide, please. So we kind of thought we were done with this draft, and then a couple of folks in the working group brought up a new issue. So that's, I think, why we're primarily on the agenda today. So the first one was raised by Paul Wouters, and that's the data format in the chain extension. He was arguing strongly that the format should be a complete DNS message rather than what it says now, which is a sequence of wire format DNS resource record sets. I believe, after some back and forth on the list, that he has been successfully persuaded that a full message isn't needed. but I'll stop here for a few seconds in case he or anyone else has any comments on this issue.
Yes, I'm convinced. You're right.
Okay, all right. Anyone else?
Yeah, so like going once, going twice. Oh, somebody's getting up. Here we go. All right.
Okay, someone's going up.
Protože po Czech CZNIC, as it's already implemented, it seems to me to be okay, just send the RRs and not the full message because it will be useless basically.
Okay.
So go on with this version.
Okay, thanks. Next slide, please.
All right, great.
All right, so that leaves the last issue that was raised by Victor. Hopefully he's in attendance remotely via mic. And that's vulnerability of this extension to PKIX downgrade attacks. So I want to say that this issue was well known to the authors and actually documented in the draft with possible mitigations. And it's fundamentally tied to the fact that this protocol, as it's written today, does not provide authenticated denial of existence. And what that means is there's no way for the TLS server to cryptographically prove that it does not possess a signed TLSA record. Victor is suggesting that we need a more robust defense. Okay, so I have a few more slides, but okay, go ahead.
No, go
Cool.
ahead.
All right, next slide, please. In case you haven't been following the list, I'll briefly describe what the attack he's concerned about is. A TLS server has a valid DANE record, but an attacker has fraudulently obtained valid PKIX credentials, and then manages to induce the client to connect to it via spoofing or man in the middle somehow, ignores the DNSSEC chain extension and offers just plain PKIX authentication with the fraudulently obtained credentials. Next slide, please. So the position of the authors on this was that this was preventing these kinds of attacks was not an original goal of this draft. I remember in the very early days of this draft, when we had discussions with some web browser folks who were interested at the time in implementing this, that there was a debate about what it means to publish a TLSA record. Is that actually a policy signal that compels the use of DANE, or is the use of DANE entirely a client-specific decision, a local decision, right? So the extension as it stands, it provides a mechanism to use DANE if you are able to connect to the DANE server, but it has no facility to mandate the use. However, in the draft, we describe mechanisms by which the client, if it wants to be sure it can use DANE, how it can do that. And the two methods that we offer, the first one is a kind of a trust on first contact mechanism where if you connect to a server, it offers DANE, you remember that fact for some specified period of time, and then you enforce DANE on subsequent connections. And the other one was to just whitelist known DANE servers. Go ahead.
Okay, Paul. So first I'll channel myself. I think if the server removes the DANE record, it should, in the extension, put the denial of existence of that DANE record in the extension. So you just get the NSEC change or the NSEC3 change that say this record is no longer there. And then so if the server validly removes the TLSA record because they change their mind on the policy of using this extension, they should run for a while with this extension with no TLS record in it, so that anyone who's contacted the server before now knows that there's a validly signed answer saying, I stopped doing this. And then it can do local policy in determining how long or when it decides that it can accept the connection without the TLS extension at all. I do think that when the client connects and the TLS extension suddenly magically has disappeared, that it should do something. But I'm happy that it's a local client policy. It can decide, oh, well, I will go use the real DNS instead and see if I can get the denial of existence answer there. If I'm not under attack, or if I'm under attack and the DNS is also blocked, I don't know, I'll tell the user this looks fishy. I'm fine with all of those solutions. Now, putting on my hat of Victor Duchovny, he is saying he really wants some sort of time period associated with this extension. So when you feed this extension, it means like, you're pinning it for 30 days or for, actually, I think he's thinking of a year or something. He wants it to, is he there? Oh, okay, he can channel himself then.
Okay. Okay.
All right, Victor, you're up.
Oh, okay.
Okay. So I just want to highlight the fact that the extension, to be adopted, has to be useful for something. And presumably at scale rather than just a few niche, cases where a priori that you can do DANE. And because it's not currently in the field, most servers are not going to have it. The only way it's going to be useful is if it's useful incrementally, right? So some servers have it, some don't. And the question is, what advantage do the servers who have it gain by publishing this extension? If it can be trivially stripped, and the client just, right on the spot for each connection says, oh, well, that server doesn't do it now, so I'll just proceed as normal, then the extension offers no security advantage, right? So either PKIX is secure, and then it's secure, and why bother with this thing? Or there's a flaw in PKIX, but then it strips Dane potentially. So I'd like to see some purpose for this. And so the client has to have some sort of sticky mechanism. Now, I heard Schumann mention that clients will decide for themselves how long to implicitly pin the extension. But I'm not convinced that that should be solely a client-side decision. I think a server operator who's deploying this for the first time has a much better idea of the likely length of their commitment to continuing to support this in a comfort level than having clients remember that this extension is promised. Excuse me, I have a bit of a cold. Some servers will be able to, server operators will know that they're committed for this forever, indefinitely, whatever, they'll do it until they provide a valid denial of existence. And we need to make sure that the packet format supports denial of existence, NSEC records, as Paul mentioned. And other servers may only be comfortable initially for days, weeks, months. But it would be good, I think, if that signal were there. On the other hand, if there's, if everybody likes guidance which says something like 6 months or 3 months or whatever, and we think that's long enough to protect most clients that, if they haven't come back in 3 months to a site, perhaps they'll never come back. Then maybe, some fixed period can be recommended. But without any recommendation to store the server's Dane capability and insist on it on reconnect until the server provides denial of existence, I think the standard is kind of useless, and I want to avoid it being useless.
Eric Criscola. Well, I agree with Victor's security analysis. I think this goes to the very heart of the rationale for this document's existence, which is, I understand the rationale for this document's existence to be that certain people didn't want to get PKI certificates, and they wanted to find a way to authenticate from the server to the client via Dane rather than PKI, and that the composition of PKI and Dane temporarily was effectively like a stopgap that would let you get that you bridge for people with the sort of temporary period where clients ostensibly maybe had both. I never found this particularly persuasive, but there you are. If the rationale for the feature is that it's only useful for, and hence all of that, the fact that you strip the thing all along. If the rationale for this feature is it intended as to stop compromising PKI certificates, like it needs to go entirely back to the drawing board, and not have this stuff tacked on at the very last minute after AD review. With that said, the idea that clients are going to take the existence of Dane and then refuse to not accept Dane for any period of time is completely out of touch with the way web servers are deployed. So I have a big farm of web servers, and I turn on Dane on 10% of them, and then clients come back, and they all have the same domain name, the same origin. And then clients come back to a different server, and now they just can't reconnect. I mean, we're in the process of people are in the process of trying to rip out HTTP, which is a much, much better story about not breaking your stuff than this does. But even so, it's too terrifying to run. It's simply not viable to have a situation in which the clients unilaterally decide that just because you display Dane, they're not going to accept PKI in the future. I mean, it's just not going to work. And frankly, I don't think it's going to work. I don't think a mechanism where the server says that is going to work either. But certainly, having the client unilaterally decide is not going to work. It'll make it totally in the blue.
All right, Richard, then DKG, and then Victor.
Richard Barnes. We erred when we put two distinct things under the same label, Dane. So Dane does two things that are pretty different categorically. It can restrict the set of certificates that are acceptable for a domain, and it can add to the set of certificates that are acceptable for a domain. And as Eric pointed out, those are very different cases. This mechanism works just fine for the additive case. You don't run into any of these issues around pinning. It's just another way to deploy a certificate and have it be trusted by clients. You still have incremental deployment issues because clients will incrementally support this. But in the case where you have clients that are capable, it works just fine and you have none of these issues. It's only when you go into the restrictive cases that any of this comes into play. So I would suggest that perhaps the way to address these issues that Victor is raising is to just make that decision to explicitly scope to the additive case and say this is an additional authentication mechanism, a way to assert additional certificates that you might not trust natively with your PKI stack. And the restrictive uses of Dane are not to be used with this extension. And you could add some 2119 language in there to restrict the, I forget what the name of the code point is that says whether you're in the restrictive or assertive cases, but you could restrict the code point in the TLSA record to say this must be an assertive Dane record if you want to make it real clear. But yeah, I would suggest we rule the restrictive cases out of scope, at least for this document. I'm not saying we should never do it. But for sure, we could just copy and paste most of the mechanism we have here and add some extra policy considerations, maybe add some denial of existence mechanisms if we want to address the restrictive case later. But what we have right now, something that is shippable for the assertive case. So let's restrict it down to that and ship it.
Okay. Yeah, so I think, since one of the target audiences for this extension was the web, we originally were trying to be sensitive to the way that they see position Dane as an authentication mechanism. So the tack we were taking was a model where PKIX and Dane authentication coexist rather than Dane trumps PKIX or vice versa, or Dane is used to constrain things, right? So that's where we were originally.
Daniel Kahn-Gilmore, ACLU. I think it would be a mistake to try to tack client policy onto this draft, similarly to what Ecker said. This draft is concretely useful not just in the web case. I certainly think that the further deep dive work would really
Absolutely, right. Yep.
The idea that we're going to hold this up by trying to, I think that if you want to do client context-specific policy, that policy needs to be done in the place where the client policy is being decided, right? So if we define the mechanism, this as a mechanism for transport, and get the hell out of the way of the places that actually want to use it, those places can decide whether clients should have policies about caching or rejection or deferral or whatever. So let's get this thing standardized, and then the places like deprive, resolver to authoritative can make those policy decisions independently of this.
Yeah, and I'll mention that some of the DNS over TLS deprive implementations are already deploying this stuff, right? Yeah. Right.
Okay. Victor's next.
Victor's next.
Hi. I have a few things to clarify. The first, to Eric's point, the specific reason I want the timer in there is in fact to address his concern that you can't deploy it if you have only deployed in 10% of your farm and the clients decide to make it sticky. So if we provide a TTL in a server response and the server sets it to 0, then the client must not cache this. And you can deploy it on your farm, and once it's 100% deployed, then you can start raising it from 0. So I think an explicit extended TTL from the server is better than an implicit one where some clients will foolishly or wisely or whatever, make the decision for the server and get it wrong in some cases. So I think actually adding a single byte TTL to this, is fairly cheap and allows the server to optionally commit in a way that allows the client to expect Dane to be there next time it connects, no matter which server it connects to, or the server can say, sorry, I'm not ready to commit yet. I think my proposal specifically addresses that issue. Now, as to Richard's comment about additive versus restrictive, I think that's completely orthogonal to this extension. I'm looking for the extension to be able to be deployed on the web incrementally, opportunistically, for just the servers that have it. And other use cases, sure, deprive, great, but it should also be possible to incrementally deploy it on the web and get some value from it. And if the expectation is that the only value you get is that you can be authenticated by some clients that have an incomplete CA bundle, but otherwise you're not adding any value, and you're not protecting against compromised PKIX creds. Given that most of them are domain validated, whose strength I'm not that confident about, then I think we're fumbling this extension's value. We're not using it to really gain proper security in the web, and it'll continue to be ignored in the web. Now, maybe that's the idea, that we really don't care. It will never be done in web servers and clients, and I should just give up. But I think it's worth making it possible to use it in the web in a way that actually offers some protection, which requires downgrade resistance. And as written, there's no downgrade resistance. It's simply not there, unless the client knows that it will be there, maybe with deprive. Excuse me.
Yeah.
But at the moment, it's just not happening for web clients and web browsers. And I think it's a mistake to not support it potentially. Let's do the experiment and see if it can be used for something real.
So before taking the next question, can you advance the slide? Can I just discuss one more point? So the other way that I have suggested this is not in the draft, by the way, but I suggested it on the list to prevent the PKIX downgrade attack is to use PKIX defenses to protect against PKIX attacks, such as checking certificate transparency logs. I think someone on the list called my idea insane, but I don't really think it's insane, because we're talking about a situation of incrementally introducing Dane in a PKIX environment. So service deployers need to be worried about PKIX threats. So you may have a server that supports both Dane and traditional PKIX, in which case they're probably paying attention to CT logs. And even if it's a Dane-only server, the operator of that service may be concerned that other attackers are not able to impersonate their service to Dane-unaware clients. So then you're going to have to look at PKIX solutions to this problem anyway. So that's another mechanism that I offered, by which you may be able to gain some downgrade attack protection. So can you advance the next slide? So I'll just I think we've already discussed what Victor's proposal is, but I'm just going to leave it on the slide so that you can look at it in detail, and then we can continue with the questions.
Victor very nicely summarized what I wanted to say. So I strongly support Victor's idea that there should be one integer which says, I'm committed to doing this for next n seconds. And if it's 0, the server is not committed, maybe it's doing the rollout incrementally, right? Then the server can use some longer value. And then if the server decides, oh, this was a horrible idea and I'm going to something else and I want to rip off this extension and never see it again, it will set it to 0 again, and it will signal to the clients that this is going to be ripped off, don't cache it anymore. So I think that one integer costs nothing and will improve the draft a lot. So I strongly support this.
Yeah, so I'll mention that the change he's proposing is not only introducing that integer and the pinning commitment period, but it's also introducing an implementation that requires the servers to send a full authenticated denial of existence chain for non-existence of the TLSA record, which it doesn't do now. There is some authenticated denial stuff there. It's related to wildcard proofs and stuff, right? But not for NX domain responses. So that would be another change.
Yes, specifically the text about the negative proofs of non-existence is very, very vague, and I'm hesitant to say that it's complete and okay right now. So I think that we need to go to that part anyway. So yeah, that's
okay. Thanks.
Hi, Sharif Mansour. I had some questions on sort of this extension with regards to large-scale rollouts. So troubleshooting large-scale rollouts. So is there ability to turn it on in passive mode? Is there a way of getting from the clients some logging? For example, with content security policy or DMARC, they have sort of a report URI to return information there, and then it provides a little bit more signal so we understand that organically this code works over time.
Right. So I mean, that's something that the clients could passively inspect today. There's no explicit flags or anything that tells this is report mode versus authentication mode today.
Yeah.
But clients could examine the presence of this extension without actually using it to perform authentication of the server, that's always possible.
Sure. But I meant for the server to say, here's a report URI,
Oh,
send
I
me
see.
the logs back here, so I know if, for example, there's a setting or an issue. I know that browsers all over the internet have broken because of my deployment, and I need to do something about it.
Right. So I think the way servers will get some reporting about the use of this mechanism is by examining whether the client sent this extension to you, right? So that's the mechanism that we have today.
Okay.
But we'll think about that.
Yeah.
If it finishes the handshake, that's the other thing. Yeah.
Thank you.
Paul Ouders. So I just want to get back. So the reason we wanted to do this is because we have information in DNS with DNSSEC protection. That's where you get this information. That's where the owner of the information can publish that this information is updated, removed, or anything. So in a way, we don't need pinning because all the information lives authoritatively in the DNS. And it should be updated there, and it can be updated based, we've got TTL values that deal with all of these conditions of, migration from adding or removing this information. Now, we're putting it into this DNS extension, into this TLS extension, as an optimization and a way of making sure that we can obtain this information even if our DNS path is unclean, and even if to avoid the extra latency of doing these lookups. So this is just an optimization of using DNSSEC. Let's be honest here. So if this optimization cannot be used because suddenly you're under attack and someone has taken another PKIC cert and put it in the server, your fallback method is not to use the optimization and go look in DNS. And if you cannot look it up in DNS separately from a separate path, just assume you're under attack. So to me, I think we do not need any kind of pinning in this extension because we've got the exact lifetimes and validity in DNS. This is just an optimization where we need to do this. So the draft only needs to say if it's removed from DNS, we must make sure that this optimized path is also updated to put in the information of non-existence. So that's, to me, is the only thing that should be added to the draft. Then everything else can become just client behavior.
Right. Yeah, so I understand that. So the problem is introducing full authenticated denial in this mechanism is difficult because then it imposes a barrier to incrementally deploying the extension in the field because it requires all TLS servers to understand DNSSEC and be able to build negative proofs for the fact that they don't have a TLSA record.
Sorry, if I can answer that. So you have the reason we use DNS format is that so the extension can use DNS libraries that support all of this. So eating these extensions should be easy for all those kinds to do. If you're talking about the way how you deploy this incrementally and some servers do and some servers don't support this extension, then again, you can say in the client, they can remember IP addresses. And if you have like 10 servers on the same IP, then if you do any casting, you should just update them in groups. Like these are just standard deployments of any extension that you do.
Yeah, let me make Richard Barnes, let me make a substantive point and then I'll reiterate a meta point. Yeah. I think we've got experience in the web. So for the web case, we have experience with incremental rollout of features that restrict authentication. We've got HPKP, as Ecker mentioned, we've got CT, both of which had, CT especially, much more momentum in deployment than Dane. And it's still, we've had to be very cautious in the mechanism that people expect. CT is still pretty controversial, even as the universal requirement is on its way. And so talking about things that are restricting authentication, making them deployable, and as Paul pointed out, coming up with a fallback story when things get interfered with is super complicated and has lots of subtle edge cases and deployment cases. And, if we're going to launch down that, it's going to be a big pile of work. So back to the meta point, let's not snatch defeat from the jaws of victory here. Let's take the thing that we've got that can deploy in certain circumstances, as DKG points out, can be used for things like deprive. Let's polish it up, let's ship it, and get some use out of that. And then if there's interest in the restrictive case later, by all means, let's do the work and get something for that.
is DKG. I'll just plus one that. And I just wanted to respond specifically to Peter's point that it's just one byte. The one byte doesn't seem too painful. The byte doesn't seem painful, but the arguing about it sure does. So I really would like to avoid having to have those arguments in order to get this out the door.
And we're closing the line, and Victor's in the queue as well.
Yeah, I mean, I think, so, as I said, any mechanism which requires you to update, to arrange that the client experiences the same thing, has a consistent experience across all your servers, like, as a condition of deployment is like a total non-starter. And any like, and even one that requires the servers that have deployment to serve the Dane records and the servers that don't have deployment to serve the non-Dane, so the authentic denial of existence is also a complete non-starter. Like people deploy their web servers, update their web servers incrementally. And what you're saying is I won't be able to do that. Like you can't segregate any caster IP, it just doesn't work that way. The mechanism Victor describes absolutely work technically. But we have like an enormous amount of experience now with like several mechanisms which like have this property, and like every single time there's like a lot of hand wringing about exactly how you avoid bricking yourself. And given like the frank, relatively low level enthusiasm on both clients and both browsers and servers for like this functionality in general, like making it and frankly the extremely low level of like additional security it's providing. You know, from the server's perspective, given the like low level deployment of the client, like, you know, to require that is really going to have a negative impact on deployment of this functionality. We know how to add that functionality later if we want it, and as DKG said, we have a number of situations where clients can simply configure themselves to require this. Like, this is not going to be like you're going to write this down and then you're going to like, you know, be in last call again in 2 weeks. This is going to be like you're going to spend a year doing this.
Eric Niger, Akamai, kind of add on to that. I think the key pinning stuff, the PKP stuff from HTTP is a really good thing to look at in terms of how badly that's failed and all the problems with it. And in particular, it's not just the can you brick yourself, which is a huge foot gun, but it's also the security vulnerabilities associated with that, and that it's being used for ransomware attacks. And what you can see here is once you do this, is even as a restrictive mode, the state of DNSSEC is not great right now. Like this MapRG talk was talking about how many people are using non-rotating RSA 1024-bit keys, is you now get into a situation where people just start pinning, compromising those keys, pinning, and then trying to pin these records in to brick people who aren't willing to fully go ahead and deploy things. And that seems like it could make things worse rather than better, even for the restrictive case.
Right, yeah, so I agree there's a danger there. I just want to clarify, the pinning we're talking about here is not pinning keys, it's pinning knowledge of the existence of Dane. But I understand that some of the same issues apply.
But if you have someone who's totally not prepared to do Dane, or then going and pinning into a hey, you must use Dane, it's not maybe not be the ransomware one, but it means that a third party could potentially brick someone.
Sure, yeah, point taken.
Hello. Eric, I think, you know, completely misses the boat here. The recommendation in the RFC to servers can say, you know, send 0 for a long time until you're ready. There is no bricking involved here. Bricking is far more likely if you don't indicate time from the server, because clients will make the wrong assumption because they need to, right? If the server can explicitly send, you know, don't cache it, I'm not ready, then the client will know the server is not ready. As to Paul's comment that, you know, you can fall back to DNS, unfortunately, that's completely wrong, because the reason that that clients don't do the DNS lookup is because it's too slow. You're not going to do it for every server that fails to offer the extension. You know, right? The web browsers have avoided this precisely because the cost of all the extra DNS lookups is too high. And so the web clients are not going to, you know, do the fallback for every single server on the web because it looks like all of them are under attack. So that fallback isn't going to happen. The pinning is just a single bit. There's no bricking risk here. We're just asking the server to not stop offering the extension for a time of its own choosing. And let's be quite clear on that. It is not the client that decides the time. If we don't specify the extra byte, then the client will, in fact, incorrectly make assumptions in some implementations. Right? In the future, let's future-proof the standard by making it possible later when it's desirable for the servers to offer a non-zero cache time. We can, in fact, write the recommendation that initially servers should always put 0 there for the moment until we gain more experience with it. And then later they can start committing to it, right? When they're ready, and then clients can start caching it. But let's future-proof this and make it useful. It locks out all kinds of use cases by not having that element there.
So we are going to break the protocol and let our soon-to-be AD talk, and then we're going to clip the line.
I mean, just sort of as a process question, if the objection is for a totally speculative use case, we have lots of space in the extension code points, and if the speculative thing wants to happen later, it can get a new code point.
So I think what I'd like to do is get a sense of the room. If it was kind of brought up that we have the current draft is sort of additive in its authentication mechanisms versus being restrictive. And I'd like to get a sense if people think that this additive authentication without any sort of pinning or denial of non-existence. I think I got that right. Yeah, I think we'll do a hum. To make sure that to see if people think there's still value in the additive case, in just an additive authentication mechanism. So I'll ask 2 questions, and we'll do it based on this draft to make it a little bit clearer. So do you think that the current mechanism in the draft is useful and sufficient and should go forward? Or do you think we need to make a change? And the second question would be, no, you do not think that the draft is sufficient to go forward. And we need to make some sort of change for denial of existence.
Sorry, Carl. So I find the question rather confusing because if I like this extension to move on, but I don't like the additive option, you're sort of telling me to vote no.
So we're not restricting the other option from being worked on in parallel, but it would be in a different draft, right?
Can I clarify the clarification?
Yeah.
So I think Richard proposed something that said there's only certain types of Dane records this allows to send.
Right.
And it's not clear if we're saying, yes, go ahead with that, or if we're saying, don't say anything, like, don't put any restrictions on the current draft. Maybe put a little bit of guidance in the current draft that says, note that if you put restrictive things in there, clients may disagree about what to do with them, right? There's a difference between saying, this is only possible for putting, and I wish I could remember whether it's Dane 2 and 3 or Dane 1 and 4 or Dane, I don't remember what the numbers are. Right, there's 4 kinds of Dane. And Richard's proposal was we only allow this draft to ship 2 of them, whatever those 2 are. I can't remember.
Yeah, it's 2 and 3.
Thanks. I knew somebody in this room probably knew the numbers. And so it's not clear which direction. Like, are we saying we should add that explicit restriction, or are we saying just put a note that says we encourage the use of this with 0 and 1, and there be dragons with 2 and 3.
Let me suggest a slightly different home structure. The fundamental question is whether we wish to have any pinning mechanism whatsoever stuffed into this thing. So, like, whether we expect it to be the case that clients enforce continual use of Dane under some circumstances. And
so do you mean any kind? Do you mean the NSEC3 or the NSEC denial?
I mean the NSEC3 one or Victor's one or anything. Right now the situation is that, like, the null hypothesis is that clients may be configured to require Dane, but that otherwise they don't, like, learn that they ought to have Dane. They just take it as it comes. And I agree that a consequence of that is it's not useful for restrictive use cases, but that's not like, that's text, it's not protocol. And so I think we should first decide whether we want to do anything along those lines. And if the answer is yes, then like the working group has to like spend a bunch of time trying to figure out what that thing is, whether it's Paul's variant or Victor's variant, or some other variant. And if the answer is no, then we can then discuss whether the document ought to be more pointed about how the non-additive use cases are not actually useful.
Okay, I think that would be a better, so the question would be, do you think pinning is required or to make this at all useful? Or do you think we can move on without having pinning in this draft?
Yep. I agree. Better question.
Okay, good. All right. So first question will be on if you think pinning is required to make this useful. So if you think pinning is required to make this useful, please hum.
Paul, you supported pinning. I didn't hear you hum.
All right, so if you think this draft is useful without pinning the way it is, please hum. Okay. So that's pretty clear. So yeah, you can get up to them. I'm sure Victor was humming, but we couldn't hear him. So, but yeah. So in summary, the general feeling of the room is that this draft is useful without pinning, and I think that's kind of the direction we're going to try to take it on the list. This doesn't preclude us from developing a pinning extension. And if, people think that's really critical, then that work should be, started and continue.
Would that definitely be started in a different draft, or might this be amended? Right, because then there's different drafts. So in effect, there's been no changes to this draft. And any new work to it would happen in a different draft anyway. We get the discuss this cleared, should this be approved today? If new work would happen in a different draft in any case.
The new work might not have to do with this particular draft at all. It might be a client context specific draft, right? When you're using this for protocol foo, there's this kind of pinning that happens, right? It doesn't need to happen in this draft. It could happen somewhere else.
So that's my point. So is there any reason to hold this up?
No, right. So I think that we're going to try to move forward, and
I think there are still a couple of discusses that weren't cleared. It might just be,
yeah, I think we just have to
clear them, but I think I should try to get that done then, sounds like?
Yeah, I think we have gone through the other issues that were needed to be cleared. Yeah.
So again, I think if there's text added that said if you've put in a TLSA record before and you remove it, you should put in a denial of existence proof. Would be extremely helpful for those people that already want to do more and want to think about pinning later. And I don't think it actually harms the people who don't want to do that. So it would actually be a really good feature to add to and it's just doing the logical thing.
Could I ask the authors to post a revised version of the draft immediately following this that removes the one word that was agreed? And with that one, it's a removing a normative, so I see no issue, because if we were increasing, then that might be the case.
Right, yeah, so I think we're ready to push one out today, right?
Post that today?
Yeah,
Thank you very much. Early in the day as possible.
okay.
For
Yeah.
processing purposes.
My discussion was solely on the basis of not claiming this was standalone. So as long as you fix that, I trust Kathleen to manage it. I'll pull my discuss now. It's just to.
Okay, thanks.
Yeah, I knew you were ahead.
Right, and then, so, for the subsequent version that includes authenticated denial, possibly in a new draft. I'm happy to work with Victor and Paul on that as well, right? But I guess, we're advancing this one as it is, right? Okay, thank you.
All right. Cool, thank you.
Okay.
Thanks. So one of the reasons the exported authenticators have been kind of sitting on it is waiting for some formal analysis, and now we're going to get to hear about that. So thank you.
Hi, I'm Jonathan, and I want to talk about formal analysis of exportable authenticators. So what are they? Very briefly, they're a post-handshake authentication mechanism that's supposed to replace TLS 1.2's renegotiation and provide a more versatile version of post-handshake authentication than the post-handshake client authentication that's already there. So how is it more versatile? It allows multiple identities for the client and the server. Next slide, please. Okay, very brief version of the protocol. Either party is allowed to send certificate requests and they get back an exported authenticator, or the server can just send an exported authenticator. And the exported authenticator is certificate verify finished, which is just copied straight from the TLS handshake, and because that's already been quite well analyzed. So next slide, please. So what are the actual security properties we want? If I receive an exported authenticator, I want it to prove that the person who created it has the private key of the certificate, and I want it to prove that the person who created it knows the master secret of the TLS channel to which it's bound. However, it actually transpires that those two properties aren't enough. Next slide, please. And the property that we actually end up wanting is compound authentication. So if I have a run of layered authentication protocol, and at least one of my peers' identities has not been compromised, so one of the peers' secrets is unknown to the attacker, then I know that the peer agrees with me on everything, all the identities and all the bindings. So this is a bit of a counterintuitive property. It's actually a very powerful property, but basically it says that in our case, that as long as either the TLS channel is good or the private key of the certificate is uncompromised, then we've got what we want. Next slide, please. So what we did was we did a two-part analysis. We did a manual or by hand proof, and then we did a tool-supported proof. So our by hand proof used channel bindings, which I'm going to talk about in a moment, and we used it to prove compound authentication as defined in the literature. And then we built a Tamarin model and used that to explore the specific security guarantees we can get from draft Sullivan, which is the exported authenticators draft. Next, please. So manual proof. So we use channel bindings as a framework to analyze exported authenticators. So channel bindings refer to the cryptographic binding between, in our case, the exported authenticator and the TLS channel, but between any of the two layers of any of the multiple layers potentially of the protocol. The thing is, numerous examples of layered authentication protocols in the literature fail to achieve this compound authentication guarantee. And it's really easy to get wrong. And so we used contributive channel bindings, which are defined by Bhargavan et al., to formally verify whether we achieve this quite powerful property of compound authentication. And basically it means we can prove that the TLS channel and the exported authenticator are bound to each other. We then did a tool-assisted proof, and so we did this secondary proof such that we could explore the guarantees that we get. So the compound auth property, as defined in the literature, says under a particular threat model, you achieve a particular property. So we used Tamarin to explore what happens if we change the threat model and what happens if we vary the property and try and prove this sort of in-between thing. And another benefit of Tamarin is if it says no, then you get a counterexample that says, here is a run of the protocol that breaks your property. Next slide, please. So the result of our overall analysis is that, yes, the TLS channel and explicit authenticator are securely bound to each other and achieve compound authentication. So what that means in practice is, to forge an explicit authenticator, some attacker would have to know the master secret of the TLS channel and the private key of the certificate. So, you know, basically the attacker knows all the secrets and you lose, but otherwise you're fine. But what that means is, if the master secret is uncompromised, so if you don't have a threat model that considers the master secret being compromised, then you have a joint authentication between two EAs. So if I receive two EAs over the same TLS connection, I know that they were both created by the same person. Next slide, please. So this was, you know, a little bit unexciting from a formal analysis. It just said, yay, everything's fine. So I thought, how far can we push this, right? Can we get even stronger guarantees? And actually, how far can we push this before this breaks? You actually have to have a ridiculous attacker model before things break, which is if the attacker can compromise the master secret and knows some private keys, because the explicit authenticators are not explicitly bound to each other, you can't guarantee that they're all created by the same person. And that's what we're trying to prove, that all the explicit authenticators are created by the same person. And we're working on potentially stronger version, if anyone wanted it. So is this a threat model that's actually plausible? Well, potentially. If something like draft green or draft RHRD had been taken up, or even if the industry decide to just export the server keys to enable visibility, that could potentially break exported authenticators, because the overseer or the monitor, or whatever you want to call it, could insert exported authenticators onto a connection in either direction, and they would be indistinguishable. And I think that's, I'm saving my one more slide if anyone asks a particular question. Yeah.
Hi, Chris Wood. Thanks for doing this. This is great. Just a quick question about the Tamarin model.
Yeah.
Is the source available? Just
I can make it available if you want it.
That'd be awesome. Yeah, thanks.
Oh yeah, my last point is if you want the stuff, email me.
Yeah.
Yeah. A paper is forthcoming.
Excellent.
And thanks for doing this. You know, we were a little concerned about what the properties of the system were. Yeah, so it's good to know that at least we have some of the properties for the IETF. What did you want to? These groups need anything?
Yeah. No, Martin Thompson. No, I guess the difficult question for the room here is whether or not we care about this threat model enough to do something about it. And I'm talking to Jonathan about this quite a bit. And there's a fix, right? There's a fix for this, and it simply means some modifications to the protocol. Now, these modifications can be essentially voluntary in a sense, but there's some value in having the counterparties actually understand what's going on such that they can extract this information and use that information concretely.
Yeah, so there's two versions, I guess, of my fix. One of them is doesn't require any on-the-wire changes. It just changes. So at the moment, there's a requirement on the certificate request context have a particular form, i.e. it's less than a certain length, and that's the only requirement. And so we can use that to pack some other stuff in it, or this could be done as a TLS extension, and then that requires on-the-wire changes, but you can achieve bindings between different EAs.
So speaking for myself, I think that it would be a reasonable tweak to the formula to actually add this. I suspect that we might be able to do it as a separate document. And so if we do that, then I would rather have it be explicit rather than doing something with certificate request contexts. But if we build that little extra piece, then we can get some sort of assurance that not only do we have this property in the case where the master secret or resumption secret or anything that's derived on that particular path is secure, but also we have the property in the case where, hey, someone decided to put the master secret somewhere, and it's belt and braces, but it gives you that little bit of extra surety about how things are operating. And it doesn't appear to cost all that much. So for context, you put the finished message from the last one in the next one, and you're done. And that's relatively straightforward.
And a number.
Well, yeah. There's a bunch of ways in which that fails, and you have to deal with that, particularly in the usage model that we envisage for HTTP. But essentially, that's the intuition that you have.
Yeah.
And it's pretty straightforward, really quite simple, and it can fix a bunch of problems. You can't make it implicit, unfortunately, which would have been a great way to do this, but we're not quite there yet. We don't have reliable protocols, it turns out.
Ben Kaduk, so Martin just asked, do we care about this threat, basically, and just to make it really clear, any attacker can get a certificate and the private key for it. So this sort of degenerates to the case where the master secret is leaked, and we have examples where that happens. So
yes, correct.
We care about it.
But it's whether you're worried about an attacker who has a certificate you care about, because all you can do is anybody can get a particular certificate, whether they can get a certificate you're worried about.
Right. Well, I mean, there's potentially the semantics of, I get the master secret for some connection to google.com, and I have the certificate for, Honest Ahmed, and now I can give you some authenticator that seems to indicate that Honest Ahmed and Google are the same thing.
Yeah.
And depending on how the client interprets that, the problems could be pretty bad.
Yeah.
Mike Bishop, Akamai. So I had a question about the proof that they're bound to each other.
Yeah.
The draft currently says that having seen one of these, you can't make any assumptions about them being related to each other in the future. Like if you do a resumption and you have a new session, you can't say that, well, this got bound to the other thing before, so it must still be there. Do you think that we could or should loosen that based on this proof, or do you think that's still a reasonable restriction?
So actually, you'd have to completely redefine the draft, because if you do a resumption, the master secret changes. Okay. And so you actually do lose the binding completely. Okay. But you could do some fancy stuff to try and achieve a cross master secret binding, but I don't think it would be very easy.
Okay. Thank you.
So Martin Thompson, thanks for doing this. Where's Nick? He was the one who didn't want to do anything to accommodate this use case.
He's hiding.
Come on, man. I want to hear.
I mean, so to be clear, Nick put him up to this, so.
Right. And this is great, right? This is awesome. We now have at least some degree of surety that this is not insane, which is way further than we were before. So.
Yeah. Because I mean, that was the reason why we yanked it out of the base draft in the first place, right? So then,
Yeah, thanks for doing this, Nick Sullivan, Cloudflare. Thanks for the analysis. I'm not entirely convinced that the compound authentication adds a lot, at least in the use case of additional certificates, the HTTP2 BIS draft. The threat model seems a little bit bizarre in that you have a connection that you've established that you're going to be using to send these authenticators, and it is compromised partway through, where the connection has been compromised partway through, and the exported authenticator had been put on the wire before a key update mechanism. So Otherwise, you can, if you do manage, if you compromise a certificate, all you need to do to sort of chain them up is to hash the previous certificate. So if you have the traffic keys, you can see previous certificates on the wire and construct a joint authenticator. Is that not true?
I don't think so. I think you'd need to know, the read-write keys, but you also need to know the exporter keys.
Right, so you compromise the connection, you have the exporter keys.
Yeah.
And you have the read-write keys.
Yeah.
And therefore you should be able to construct a chain of exported authenticators.
You can,
unless you only compromise the current set of traffic keys after a key update.
The guarantee you would get in the joint case is actually only until the last good certificate. So if I knew that a particular certificate was compromised, I could still, so I'm, whatever, Cloudflare, and I know one of my certificates been compromised, and then I have another certificate that is now good, then I can join those together as long as, but it's only, you only get the guarantee for the last good certificate and all ones before it. So if you're worried about a future compromise within a session, then yes. Yeah.
Right. So I think from the analysis, it seems that the current draft as written is relatively robust with respect to being able to add a certificate to and associate with the connection, not necessarily with other certificates.
Yeah, that's robust.
And my recommendation would be to go forward with that, and then have, if there was a demand and a need for this stronger compound authentication and it had a specific use case, that we'd go forward with a different draft on that would build on it explicitly with the TLS extension. That's my thought.
I think Martin agrees with you. Yeah.
Becker?
So, I mean, I'm not opposed to changes here. I've seen a lot of work over the past couple of years and people trying to create create situations where partial compromise behave properly. I mean, all this work on MCTLS and stuff like that is really about that. And my experience is the answer is typically pretty terrible. And that if you go to a lot of trouble to try to design protocols in those cases, often they don't achieve their goals. If there's some, and certainly if this had been published, if we published this document, right, and then you discovered this property, this would not be oh, I got a vulnerability in TLS, right? Though it's a really nice analysis. To the extent to which it's trivial to make a change that makes things better, I'm reasonably okay with that. But I don't want to jump through a lot of hoops to make it be the case. Master secret's compromised. Don't do that as the answer to that question, right?
Yeah. So the answer to that is actually, as the draft is now, you could also use my stronger version, because the draft says pick any value as long as it's long enough and unpredictable. And so I can just say pick that value to be this shape, and you get the guarantee. So yeah, you don't actually need any changes if you don't want them. Okay. Or you could define a second.
Yeah. Like I said.
Oh, sorry.
So Martin Thompson, not quite, because unpredictable is not the case if you're picking a finish from a previous one. So there's a change there. And so I'm inclined.
It's a should unpredictable, not a must unpredictable.
Yeah.
I think it probably should have been a must, because otherwise you have replay problems. It was intended to be, the reason why we had a particular value was precisely was to ensure that the certificate had the proper private key at that moment as opposed to some moment in the past, right?
Well, yeah, it has to be fresh, but it doesn't necessarily have to be unpredictable.
But it has to be, but fresh isn't enough, because imagine that what I did is I just used a counter, right?
Yeah.
That's fresh, but the problem is the attacker compromises the key he's using to sign the EA at time T. And he had temporary access, right? And then he pre-generates an EA, right? If you have a random value, that hack doesn't work. But if you have a non-random value, even if it's fresh, that hack does work. So that's why unpredictable text is in there.
Yeah.
So in order to do this properly, you need to have both the random value, the unpredictable value, and the previous value. You
Yeah, so
plug them together.
I
You can actually do that for multiple of them.
Yeah, so my CRC packing change has a sub CRC inside the CRC, but yeah, it all works the same.
Yeah. So I think your design, which you should probably share with the working group at this point.
Yeah. Sure.
Just so everyone has all full context, does actually address this question reasonably well by actually putting both values in there. That's fine.
Yeah.
But I was actually going to suggest that what we might want to do is, given that there's this self-service option available to people that sort of want to do this, we leave the self-service option as a possibility, and we leave open the possibility of adding an extension to have the explicit communication about the fact that the self-service option is there, or have some sort of explicit way to bind things together in the future. But I think we can probably proceed with the draft as is, based on the feedback that I've gotten from the people here. That would be reasonable, I think.
Yeah, I mean, one thing I want to mention is, as I understand it, because the way you're designing, because the binding includes a previous, finished, right? Now you created a new application invariant, which is these have to be done in order, and these have to be done in order, right? So right now the application invariant, they don't have to be done in order. You could do, you could make two requests, you could do two support authenticators, and they could be delivered in either order, right? And,
Sure.
And so if you have two tokens or something, that actually could kind of happen, right? And so if you bind them to this way with a linear structure, then they have to be done in order. So it creates a new application invariant. So it's not.
I actually share my document with you. I discussed that at fair length. TLS sort of provides in-order delivery within one direction.
TLS provides order delivery, but it doesn't mean that the client does the order.
Right.
And so, so it's not strictly straightforward.
Yeah. So what it basically boils down to is you don't actually build a linear thing. You build a tree, and if you have certificates EAs crossing in midair, then you might end up with a tree that splits, and then each side has to process one more EA.
Right. And now we get back to my thing about this is getting very complicated.
Yeah. I mean, I can reason about it. Fine. Yes.
Right. Ben Kadex, just in a similar vein, you could imagine an endpoint that says, at the start of the connection, I know I might need to authenticate with these certificates, and let me generate the authenticators and then throw away the exporter master secret. And
no, you can't do that.
That's true.
All right, so I think we got to wrap up here. So I think what basically I've been hearing is that we can progress forward with the kind of draft as is, and then if we want to have a more stronger mechanism, we need to do it in another extension. And you're going to happily provide a paper for us, right?
Sure.
It'll be great. All right, cool. Thank you very much.
Thank you.
Who's next? All right, certificate compression.
Hello, I'm Alessandro Gadini from Cloudflare. I'm one of the authors of the certificate compression draft, along with Victor from Google. Next slide. A bit of context first for those that missed the previous discussions. We want to compress certificates for a couple reasons. One is quick. Quick handshake combines both TLS handshake and connection establishment in the same mechanism. So it reduces the amount of round trips required to establish a connection compared to TLS over TCP, but it also makes it very easy to mount reflection attacks with a fairly big amplification factor. So Quick provides an optional source address verification mechanism, which adds an additional round trip to the handshake. But if we can reduce the amplification factor, then we can remove the need for this address verification and the additional round trip, at least in some cases. The other reason is that sending fewer bytes can be advantageous for TLS over TCP as well. Fewer packets are needed that can be lost and would need to be retransmitted. Next slide. So it turns out that compressing certificate is actually quite effective. Victor presented some measurements he did at IETF 98. From a sample of a few thousand certificates, he measured a 30% size reduction at median and almost 50% at the 95th percentile using broadly. And of course, fewer packets then are needed to send those chains. Next slide. The draft went through a few rounds of discussions already, thanks to everybody who participated. We now support both compression for server and client certificates. For server certificates, the client advertises the algorithms it supports as part of a client hello extension called compressed certificates. And then the server, if the server decides to compress, then it sends back a compressed certificate message rather than the usual certificate message. This message contains all the information needed to decompress as well as the compressed certificates. And of course, if the server doesn't want to compress or doesn't support compression, then it just sends the normal certificate message. Next slide. For client certificates, the server advertises the algorithms it supports as part of the same extension, but this time inside the certificate request message. And then the client sends back either a compressed certificate or the normal certificate message. So the main point here is that server certificate compression and client certificate compression can be negotiated independently. Next slide. One change that we did was to only define this mechanism for TLS 1.3. One reason is that extensions as part of certificate request are a TLS 1.3 feature, but also this prevents middle boxes from intercepting compressed certificate and then get confused by it, because in TLS 1.3, certificate and compressed certificate would be encrypted. Next slide. So we think the design is mostly done. So there are a few changes needed to the draft, mostly editorial, I think. So we are at the point where we can actually start implementing and deploying this mechanism. And we asked the chair for early code point assignment to make this smoother.
So the basic premise of this is that they think they're ready. We've asked enough questions. They've changed some things around. Are there other people that are planning on implementing this to experiment with this so that we can actually start the early code point assignment? That does not mean that the draft is done, but do people think it's clear enough and stable enough to actually get an early code point assignment? That's really the question now.
Eric Criscola, I think we, by which I mean Firefox NSS, would be interested in experimenting with this. I guess my expectation is that actually we'll probably need another early code point assignment later. I mean,
They're provisional, right? So you get them for a year. And then
yeah. I guess all I mean to say is like that that just based on my previous experience with this kind of stuff, like we're going to probably find some stuff we don't love and we have to change. But we like a lot of code points. So I mean, I think the early code point assignment, mechanism is not really a great fit for the kind of work we do here. But given this one we got, I think if the chairs and AD are going to bend the rules a little bit, I think it's fine to do a code point assignment that we squat on here, right? I mean, like this is the the two mechanisms we have are basically like we just write something down in the wiki and like then we squat on it, or we do a code point assignment and then we squat on it. And either case, the thing that either we go with the RC that applies the RC version, or it decays within a year, and then eventually we can use it again in a year or two. So those seem basically the same to me. So I think it's fine for us to start using.
Yeah. Phil Baker. As a general thing, I think that we shouldn't make code point assignments a barrier to innovation, because if you do that, you'll never ever be able to experiment because you'll never get the code point to do the experiment.
Right. So generally, that's why we're doing the IANA registry draft update, right? Is to kind of lower the bar so we can do this. So that's, I mean, I'm kind of like, are people violently objecting? And if no one is, then great, we can just get that process started. It's a process thing where I send a message to the mailing list and we go, yeah. So the ADs have something to watch. And yeah.
I do have one question though. You said that it was 30% less bytes in the compression. How much is that as a reduction in bytes? Because I mean, like, if I'm doing an RSA certificate versus ECDSH, I mean, like, RSA keys and signatures ain't going to be compressing much. So, I mean, like, it's the number of bytes that I'm interested in.
I'm not sure on the number of bytes Victor did this, but the compression is over the whole certificate. So, of course, you could, for example, use ECDSA and compress that, and then you would get a higher compression.
Well, yeah, but RSA, random numbers don't compress. So
yes, it's the all the other stuff in the certificate that compress.
Right.
Ian Sweat, Google. I'm very supportive of this as a person who operates a bunch of servers that I don't want to make them replay attacks, and I also don't want to make all my handshakes take 2 RTTs. So obviously, like, yay, thank goodness. Because I mean, if people looked at Victor's numbers, my memory is basically without this, something like half or more of certs are large enough that under the current quick guidelines, you would have to have a 2 RTT handshake if you didn't have a resumption token.
Firstly, I think that we'll be interested in having an interrupt with this. Not that, I'm not sure if we'll, deploy it, but.
Yeah, sure. That's all.
Channeling Victor Vasiliev again. It's fairly often a reduction on the order of a kilobyte or more.
Chris Wood at Apple. Yeah, we'd also be interested in experimenting and doing an interrupt with this as well. So.
All right. Comment, Chris. Facebook is also interested in experimenting with this. One comment I have, the certificate compression type space is just 1 byte right now. We might want to consider making that 2 bytes to.
So we currently really only have 2 algorithms. I think we might consider it. I'm not convinced that we need 2 bytes, but.
So one thing we might in the future want to do some of those dictionaries and just provide this room.
So one point is that right now we don't do compression dictionaries. So to actually add dictionaries, we would need to allocate more code points. So that might be.
I think given that we're now at the point where we're talking about deploying it and there's some cost to us to grabbing another code point, I think probably it'd be worth making that 2 octets, as Kyle suggests. But if compression dictionaries, you might have more than 255 compression dictionaries. Yeah, you're right. Quite so, yes. Do you also, this is a question for the AD, do we need, we don't need some other provisional mechanism for registering these code points, right? Because these are just inside the context of this code point registration, right? So we don't need like a early code point assignment for Broadly, right? In this draft.
So yeah, so there'll be a registry with 2 initial values for Broadly and whatever the other one is, yeah, and then go from there. So that's the idea. If they're going to add a dictionary, it'll be another point in that. So point 3rd code point or whatever. So yeah.
Yeah, John Mattsson, Ericsson, I think this is very good work. A lot of the discussion in the new started EAP working group was about the size of the large certificate change and the problems that causes for EAP. So I'm also very interested in experimenting with this.
Cool.
Comment, Chris. Just to be clear, I wasn't asking for additional code points, just more code point space.
Yeah. All right, thank you. Thanks, that's great. We'll get that administration stuff started on the list shortly. Christian, you're up. We got 3 presentations in 30 minutes, so 10 minutes a shot. That's great. We're back on time.
Good morning. I am Christian Wiedemer. I am presenting here the state of the SNI encryption draft. The SNI encryption draft, the work started about a year ago, bit less than that. We went through a presentation. Effectively, what I did back in last May, June, was to get all the reason why we can't do SNI encryption and put them in the draft, and then collect 2 plausible candidates and put that in the same draft. And the list of reasons was first collected in June in an individual draft that's been adopted by the working group. And here we are now. I have had some feedback, but not a whole lot. And can we go to the next slide, because that's where I assess what we have. The draft has basically 5 parts. There is first an introduction which provides the motivation why you want to do that. And why you want to do that is that effectively there are 2 pieces of metadata that are sticking out on the internet today, outside of the encryption domain. One are the DNS names that you send in DNS queries, and the other one is the SNI that you send in TLS hellos. And it turns out that we have a good handle now on DNS encryption. There are several solutions that are available. So the SNI in clear text really sticks out. And that's really the motivation. We have to have a way for people who want to be discreet to encrypt the SNI or hide it or somehow. That has reasonably good consensus. Oh, you're pushing me to the 2 minutes?
I did not. Apologize.
The list of attack and requirements, both the motivation and the list of attack, I think have a good consensus from what I read in the email and then in the list. We don't have that much consensus on the proposed solutions. And one of the solutions, when the HTTP solution is not really a solution, is documentation of stuff that does exist in HTTP today. But the proposed solution using either tunneling or session resume have basically low consensus. So let's be clear. My proposition is that we want to make forward progress there, and that forward progress will mean discussing the solutions. And to do that, I would like to first, provide this list of attack in some kind of information or RFC by excising the solution from the current draft, and just publish that so that we can have a reference, and then have separate draft progressing normally on each of the proposed solutions.
Kathleen Moriarty, Area Director. I think what's lacking is a list of how this might be used by others, so you have a balance to the draft. By just listing attacks, it's not a balanced approach. So some are using SNI.
Yes.
How is it being used in non-attack ways?
You want a tutorial on why do we have SNI?
Yes, yes.
Well, we can
Because
write
if you're
that,
only focused
sure.
on the attacks, then this is not balanced.
We can write that. We can.
Thank you.
So, the big thing is normally TLS we haven't done these kind of things where we split it out, put like the kind of analysis over here, and then have other documents that explain the protocol. It's just not something we've done a lot. So it's the kind of question is, are we okay with that? Would we be okay like separating it out and having the AD sponsor the first part? And then we just work on the solutions. I don't know, that's kind of the range of questions I was hoping we could kind of like track down. So it's mostly like, we're still working on this, but how the documentation goes. So that's kind of where I was hoping we were going to figure out.
So Martin Thompson, I think this is somewhat of an exceptional case. In a lot of the other things that we're doing, there is a solution and we just need to beat on it till everyone's happy with that solution. But here, no one's really happy with any of the solutions because all of them have various costs. And there's various trade-offs that you might make in a particular deployment that would move you towards one solution over the other, or maybe you just can't deploy any of the solutions and it's just too hard a problem for you. I think this is a reasonable strategy for dealing with that. Having the description of the problem statement and the requirements and some of the reasons that people do SNI in a document helps establish a bit of a footing on which we can then talk about solutions. And the solutions, honestly, each one of them is going to be, yeah, take it or leave it. This is awful for the following reasons, but you might be able to deploy it in this situation. And I expect to have a number of them over time. And I think Christian's proposal here is a fine one.
Are there any violent objections to this proposed way forward? If there are, please get to the microphone and state why now. Sold.
Okay, thank you.
That's it. Now, Ecker, you're up again. Semi-static Nick. There we go. All right, cool. Perfect. We're back on time again. Excellent.
Okay, hello, Nick Sullivan. This is a proposed draft that Eric and myself and a few other people have discussed, which is about bringing back the idea of a semi-static Diffie-Hellman negotiation handshake mode to TLS 1.3 as an optional extension. So the TLS 1.3 key schedule, it has almost all the features that were in the earlier versions of the TLS drafts, except there's one additional mode, which is the 1RTT semi-static mode, in which this was in earlier versions of TLS in the draft, and it was eventually removed due to complexity and due to the fact that there were two methods to do the same thing, which is resumption. So what the semi-static mode is, it is rather than when you do a resumption using a PSK that was established from a previous connection, you use a Diffie-Hellman public key that's sent from the server, whether as part of the session ticket or through other means. And one of the issues we had was, what does this other means mean? There were suggestions of doing it through DNS and other mechanisms, but none of them really made a lot of sense versus a PSK. There weren't so many use cases to justify it being part of the main draft. So technically speaking, the way that this would work is rather than signing the entire handshake as a certificate verify, what you would do is you would compute a MAC over the transcript up to that point using the server's Diffie-Hellman key as well as the client ephemeral Diffie-Hellman key. Next slide, please. So the motivation for this draft is, there's multiple ones. One of which has to do with tracking, or with the idea that if you do a resumption, the server knows exactly what the first connection is, and this is trackable. And there are certain applications, notably DNS over TLS, where you're most likely to just have one interaction with the client and server during the connection. So it likely will use the 0RTT mechanism. So you end up having a situation where this first connection is actually every request to the server, although it's 1RTT, the entirety of the protocol, it is linkable from one request to another. So it's desirable to have some unlinkability from one to the next. Another motivation here is the simplicity of single primitive protocols. If you have TLS and you have the ability to have Diffie-Hellman certificates or Diffie-Hellman authentication from the server side, then you can implement TLS without implementing any of the signatures. And in some constrained cases, this is better because then you only have to implement Diffie-Hellman. You don't have to have multiple algorithms. It makes a smaller smaller code base on either the client or the server side. And on the client side, if you have key pinning or things like this, it helps. There's another thing that this contributes to is that you can mix a long-term server key into the master secret. So this is another thing that some people are concerned about, is potential PRNG failures on the server side.
Yeah, just Martin Thompson, quick question for clarification. You had one RTT involved in the previous slide, but now you're talking about zero RTT. Are you looking to restore the semi-static zero RTT mode, or are we talking about something else? That's not my understanding.
We're sort of talking about both. The draft as currently written only describes the one RTT mode, but it could be extended to potentially a zero RTT mode. And the goal of the draft is to support potentially both. Maybe Ecker can help
Yeah,
clarify.
well, no, I think there are several of us, so I'm not sure we all agree. So I think the current draft, as Nick says, really supports a one RTT mode that was like the basic operational mode of PTLS. And ECDH cipher suites with the MAC replacing the signature. Part of the reason we removed the zero RTT sort of ECDH mode was we had a lot of trouble reasoning about it, and it seemed duplicative. So I guess I'm less excited about that, though prepared to sort of engage with it. I think we have a PR from Chris about that. So I think that's the part that needs more thinking. I think frankly, there's also a lot of questions about whether or not there's any real way to distribute the keys that you need to make that work. Which I think another reason we initially jettisoned that. So I think and I think the final question is we're not quite sure how that composes, because that was definitely a source of potential security problems when you looked at how it composed other things. So.
Yeah, that's right.
Kenny Patterson. I'm only just seeing this for the first time, so I'm doing kind of live cryptanalysis here. So isn't it vulnerable to KCI attacks, key compromise impersonation attacks, where if I happen to learn a client ephemeral, then of course I can somehow impersonate that client to the server, but now I can also impersonate the server to the client because the key is only derived from that ephemeral and a long-term value of the server. Or did I misunderstand? Maybe we should let you get to the actual slide.
Yeah, we'll get to the diagram for the key schedule.
If I can learn that client ephemeral.
So I guess. No, I don't think that's correct, Kenny. So to be clear, if you learn the client ephemeral, then so as I say, your argument is if you learn the client ephemeral, then you can impersonate the server to the client, right? You're concerned about. But if you learn the client ephemeral, you can merely allow the connection to go through, and then set traffic from the server to the client. So I mean, ephemeral has no security values. Has no authentication values. Yes, it has that problem, but I don't think it's any different from the ordinary setting. It's just the server has to be on one.
My hope is that the figures later will help clarify this, so maybe we can.
Yeah, look, when we get to the diagrams of where the new keys are put into the key schedule, that should help clarify. Though I'm not sure I understand the attack, because the server ephemeral does have to be incorporated as well as the server long-term key.
No, I think Kenny's proposed attack. So I believe this is an OPTLS as well, but maybe I'm wrong. But if you learn the client ephemeral, right? So say the client say you completely guide the server. So you learn the client ephemeral. You can now generate a transcript because the client will establish a period to come from the server, because you can pair the client ephemeral with both the server's public key, sure. Right? I'm saying that is true, but the primary difference. But as I said, your alternative would be to allow the client to transmit the ephemeral to the server, capture the server side of the transcript. So imagine Shell's point of view is now. You allow the client to transmit the message to the server, you capture the server's transcript, and then you just gag the server and start transmitting directly. So the primary difference between these two is that in one case, you need the server to be online, in the other case, you don't need the server to be online, unless I missed something important. And I believe, is that not in fact a property of all these Diffie-Hellman systems?
I think it depends exactly how you mix the different key components together, so you can avoid them if you're careful. If you're mixing long-term and short-term, or long-term and ephemeral components together in various different ways, there's a bunch of literature on this, which we should. Yeah. I guess what this is really saying is this is going to need some security analysis, which we already
absolutely. Yeah, this is really a very early stage idea, and so we're trying to gauge whether there's interest in actually pursuing.
And there's in fact a bunch of hand waving in here about exactly what the mixing structure ought to be for precisely that.
Right, next slide, please. So more motivation. One of the other reasons that this Diffie-Hellman-based TLS 1.3 wasn't possible was because it's very unlikely that TLS certificates for ECDH shares would be practical in the near term, where this construction called delegated credentials makes this possible. Time-bounded key swap is sort of it says Ecker, what is this? But this is a Richard Barnes way of explaining it. Basically, it's whatever the key is used to compute the certificate verify is swapped with what's in the delegated credentials. This is an adopted draft that is still being worked through. And also, if you use something like this, then you can do you don't have to do the expensive RSA signature operation in the handshake. So this helps with server performance. There are some semi-static key distribution scenarios, such as IoT and replacement of pre-shared keys, that allows you to mix in the client ephemeral rather than just a PSK. And there are some other theoretical ways of fetching these semi-static keys. All right, so this is the current key schedule, at least for deriving master secret. And here's if you take one step forward, next slide, here is the place in which it's proposed that the semi-static negotiation, this SS is the client ephemeral with the server semi-static, it gets mixed in rather than the 0 into the extract for the master secret. Next slide, please. This would be practically implemented as a set of new signature schemes, and these would be Diffie-Hellman signature schemes. It's not technically a digital signature, but it takes the form of a signature because the certificate verifies a MAC derived from a Diffie-Hellman with this key. Obviously, these should not be in the signature algorithm certificate scheme. So the split in TLS 1.3 between certificate algorithms and certificate algorithms for the certificate is good here, because certificates are not typically signed by Diffie-Hellman entries. Yeah. So next, the last set of these are the set of open questions. Should we keep a certificate verify message? It was suggested that potentially the keys could be rolled into the eventual finish message. And rather than have a certificate verified rather than having two MACs in the middle of the handshake, Karthik will probably have some comments on this, but you could potentially have just one finished message. And can client authentication, can it happen the same way? Can you do Diffie-Hellman keys? This is not fully fleshed out. Another open question is if you're doing semi-static Diffie-Hellman, it's semi-static, you're not using ephemeral keys. So if you have some sort of Diffie-Hellman group that can only be used once, this does not work with those compared to the signature schemes that we usually work with. And then again, the question is, the semi-static key, should it be part of the key schedule, or should it only be looped into the certificate verify? This has different effects on the analysis. The analysis that we have currently of TLS 1.3 would map really closely to this if the semi-static key was only mixed into the certificate verify message rather than the actual key transcript. So, but it's not clear what the exactly right consideration is for this.
So we just need to keep it short. So.
Next slide, please. All right, so there's also, this is a pull request for, as we mentioned, mixing it into the early data and where that would fit. Essentially, that that extract value right there, rather than going directly to the early secret, is an extract from the ephemeral and semi-static.
Chris Wade, Apple. Can I just comment on this real quickly? I changed the pull request this morning after talking with Karthik about this yesterday. Basically, get rid of that nonsense in the middle with the ESS and just replace the PSK with the Diffie-Hellman of the client ephemeral and the server semi-static.
Right, okay.
And then the proofs just kind of fall out from the bottom.
Yeah, so so for this diagram and the previous one where it says PSK, just replace that with ESS.
Yeah, if you were to, yeah, exactly.
Next slide, please. So again, there's a couple open issues about semi-static reuse. You know, you have to do a public key operation to read early data now rather than a symmetric one. Is that a problem for DOS? How do you choose the PSK identity? There's definitely some issues around resumption that need to be sorted out, and these were difficult ones in TLS 1.3, which we decided to punt on in favor of the much simpler PSK. So next slide, please. So these are generally the questions that we wanted to raise for the group. Is this something people are interested in pursuing? This is an extension. Should this extension be able to radically change the handshake? You're significantly changing the key schedule here, and removing signatures from the algorithm. And also, are there anybody out there who's willing to review the draft and provide comments?
All right, so I really like this idea, because from the very beginning we thought that we could be able to bring back semi-static into TLS, and it shows how you can. Unlike Kenny, I had like a week to think about the cryptanalysis. I'm not doing this live. So from the viewpoint of all the proofs that have already been done, using the semi-static key to generate a PSK for 0 RTT even in the first message, that'll be completely fine. Using it as a MAC key in the certificate verifier will be completely fine. You can even use it for client authentication. That'll be fine. There is a KCI attack there, but it is almost inevitable when you make this from an asymmetric signature-based scheme to a more symmetric deferment-based scheme. We can talk about that, but that's mainly for the handshake. At the record layer, anyway, we are host, so that's okay. But the moment you mix in the key into the key schedule, the proofs no longer work. So we'll have to redo all the proofs that we did for that particular mode at least. So, and I don't see what the big advantage is for that, and I'd like to understand that a bit better.
Yeah, I believe that the main advantage is to keep a linear key schedule, which is maybe not a very strong one.
Yeah. No, the primary advantage of so can you go back a couple slides to show the change of the key schedule for where you're injecting the key? Right. So the primary advantage of making this change, the nominal primary advantage of making this change, is not keeping a linear key schedule, but is requiring compromise of both the server static and the server ephemeral in order to compromise it. Sorry, is requiring compromise of both the server static and the server ephemeral to compromise the connection. So in the current TLS 1.3 mode, you don't need to compromise the server signature key to compromise the resulting key. And so the not mixing this in preserves that property, and mixing it in makes it so you have to compromise also the long-term key. So the hypothesis is say you had a really bad you had a good PRNG you used to make your long-term key, but a bad one you used to make the ephemeral key, then this would be somewhat stronger. That's the only rationale I'm aware of.
Sorry. Although I think recovering from a PRNG by mixing in additional stuff is not necessary, I think you could take your semi-static key, use that as part of your random number generation, and get a nice ephemeral that you could use.
Yeah. Hi, Tyler van der Merwe. I think you probably already covered this, but could you quickly clarify and remind us why we abandoned semi-static 0 RTT to begin with? And the reason I ask is because at the TLS Ready or Not workshop, I think some of Karthik's work actually raised problems with the 0 RTT mode when we still had semi-static 0 RTT. And I know you're proposing 1 RTT semi-static, but you also said potentially 0 RTT semi-static?
So the question is why we abandoned semi-static in TLS, the working group. I think Eric stated that earlier on. It was a matter of it's potentially duplicative, and it was more complex to analyze versus the simple PSK-based resumption, is my understanding.
Okay, then I just, from a security perspective, Karthik, did you not flag something at TLS Ready or Not? With the semi-static as it was?
I remember there was some sort of issue with semi-static resumption.
Like
but
the composition between semi-static and signatures has to be done carefully. Otherwise, you have a forwarding attack, at least at 0 RTT. And but many of those things have changed a lot now, and now we're not really composing those things in the same way anymore. And similar attacks actually hold for PSK as well, but we fixed those using the binders. That's what the binders did. So hopefully the binders will solve it in this situation as well, but analysis to be done.
Right, and to be clear, this draft only, it does not support a signature mode. It's Diffie-Hellman.
Russ Housley, I like this work. However, I'm a little concerned about reusing the PSK slot. It's pretty clear that we're going to run out of time before we get to my presentation today, but I had a proposal to use that for the external PSK. And so I'd like to come up with a way where the two could both live. And I think that we can probably come up with a way to do that, some additional hash or KDF or whatever. I think that we do want the short-term quantum resistance by enabling a external PSK to be mixed in there. So I'd like to, I guess I'm offering to work together on that.
Thanks, Russ.
Phil Baker. Yeah, I like this a lot. It's always seemed wrong to me that we use signatures in TLS in the first place, because it provides a proof that a key was involved in setting up a connection that is unforgeable, and maybe that's some piece of information that I never wanted to give away. I think obviously we need to look into the security of this, like we've looked into the security of everything else, but at the end of the day, it's not like DSA signatures are entirely without security issues. I mean, you've still got the issue of if you screw up doing DSA, you screw up really badly. And so I think that that needs to be weighed in, and I suspect that when you get down to it, it's the same sort of effect that is driving all these vulnerabilities under the covers.
Chris Wood, just wanted to comment that we're trying to look at modifying CAS's Tamara model for, I think, draft 23 for 1.3 to incorporate the semi-static just to get kind of some more assurance. And we're also working with other people externally to try to get some more formal analysis of this to maybe attacks like those that Kartik mentioned or at the trial workshop don't come back to bite us.
So I just wanted to address Russ's point about the PSK. Just for clarification, the one RTT mode doesn't implicate the PSK slot at all. It's only the zero RTT mode that implicates the PSK slot. The one RTT mode implicates the zero slot, which is already zero, which we left in there for this purpose. So the only time that the PSK slot would be implicated, we want to do zero RTT, and then presumably then you have a separate problem because that's also where you're probably using the PSK slot in the handshake also to indicate where which PSK you're using. So I think you're already overloading that. So I think what you'd end up doing is having some structure in there that said, I want to use this Diffie-Hellman combination plus this PSK together, and then those are and as you said, is get HKDF to end up in this PSK slot. So I think that's very doable.
Can you hop ahead 2 slides for a second, or to the next diagram? There we go. Oh. Yeah, so something like this, where potentially the zero would be the PSK. Is that what you're saying, Ecker?
No, what I was actually saying was you'd probably have a V on the left, where you basically say, you basically say, well, you offer in the, I mean, this is like just hand waving, but you offer in the PSK extension, you offer a structure which consisted of the Diffie-Hellman, which consisted of basically identifying the server static you wanted to use, and also the PSK you wanted to use. The server would accept them jointly, and then would have a function to turn those into one thing you shove in the PSK slot. But this would work too.
Okay. Subodh.
So I see that we have a MAC inside the certificate verifier, but we also have a static secret that's wrapped in server, and other protocols like noise framework and stuff. They're able to use the semi-static secret without using a signature-based scheme like a MAC. It would be really nice if you could get rid of the if check. So MACs generally come with you have to check the MAC is valid or not at the end of it. So it'd be really nice to design a protocol which exists without having any if checks at all. The security is baked into that's it. At the end you derive the key and that's it. You have authenticated that.
So that actually, so that's actually that is what happens if you mix in the key. If you mix in the very end, the thing that Nick added, where you mix in instead of the zero, then you also get that property. I mean, sorry, you get that property informally. I'm not able to prove, I don't know if you get the property formally, but informally you get the property that like basically then you'll start getting noise, start getting garbage, right? I don't know, however, if you get the property at the end of in the CK sense, or if you only get the property with respect to the traffic keys.
Yeah, I would prefer that way of doing it than macking, like actually having the MAC on the certificate verify if possible.
We're over time at this point, so I think we have to take this to the list. There's obviously some interest since there was a lot of people at the mic, so I'd say keep going on the list and go from there. There was one other presentation that got bumped, unfortunately, Russ's draft to add PSKs in with certificate authentication. So also take a look at that and take it to the list. And thanks for your time, folks. Oh yeah, where's the blue sheets? And if anybody wants some stickers, come to the front. Yes, thank you.
He broke its neck.
Well, as usual.
All right, we need to wait and make a background. Yeah, take some more and pass them around.